merciless on her.
Okay. Well, to start off, the first question this morning, Mr. Marcus, is in 5 minutes or less, could you help us understand how a GPS receiver works in my car when I'm driving in the morning?
Okay. The first thing you should understand is GPS receivers do not transmit. They receive from 20 to 30 satellites that are in orbits around the Earth, not all in orbits around the equator like DirecTV, but orbits that are flying around in different directions. So at a given time, your car can see 4 or 5, 6 or 7 satellites above you in different parts of the sky. Each of these satellites is transmitting on the same frequency, centered at 1575 megahertz, going up 16 and down 16 from 1575 megahertz. They're transmitting all at the same time, but with somewhat different digital streams of signals. And using the same magic in the receiver that a CDMA cell phone uses or a 3G cell phone uses, they are able to listen to multiple signals and to sort them out according to their code, and also to measure the relative travel time from the satellite to the car of each of those signals. Mm-hmm. Knowing the travel time from the satellite to the car and knowing from separate information they receive from the satellite of where the satellite is at a given time, they can triangulate in a complicated way and get their position. But it's all they do is receive signals from 4 to 8 satellites at a given time, and the signals overlap in frequency, but using special technology similar to CDMA cell phones, they're able to sort them out and measure the relative distance to each satellite.
Great. And so you emphasize the word receive frequently. Can you help me understand the wireless spectrum that's coming down to the GPS, how it's being received? In other words, you mentioned the 1575 megahertz spectrum. Could you help me understand a little bit more about that spectrum?
Okay. There is a block of spectrum from 1559 to 1591 that's reserved for navigation systems such as GPS. GPS is the predominant use of that. In that spectrum, GPS transmits several signals. The so-called CA signal is the signal intended for consumer-grade receivers. CA meant originally coarse acquisition. There are 2 other signals that are present there, the Y code and the M code, that were intended for military systems. The Y code was the original one, the M code is the second generation one. Also in that band is some additional information which describes where the satellites are at a given time. And the receiver gets the consumer receivers get the CA code and the information on where the satellites are, and ignore the other 2 signals.
Great. So to reemphasize, the GPS is coming in at about 1559 megahertz.
No, 1575 plus or minus 16.
Thank you.
The lower edge is nominally 1559.
1559. Now, is
nominally.
that... No, okay. Is that where the Light Squared's proposed license is coming in?
Light Squared has a license. There's a lot of misnomer. Light Squared's had a license for a long time for Iridium-like mobile phone service to satellite. They have a license in 4 bands, but the most relevant part is from 1525 to 1559. There's actually a 1 megahertz gap in the middle, but they have a license from 1525 to 1559. Have had it for a long time. Since 2004, they have actually had permission from FCC to use that not only for Iridium-style satellite telephones, but also for dual-mode phones that could either talk to satellites or talk to terrestrial base stations. So they have been able to do what the big controversy is about since 2004, with the provision that the only phones they could sell were big clunky phones that cost $1,000 that were capable of talking to satellites as well as talking to local cell phone stations. This particular thing is not giving them new frequencies, it's giving them permission to sell smaller phones that can only talk to local base stations, which cost more like $100, not $1,000. So if they only wanted to sell $1,000 cell phones, approximately, they've had permission to do that since 2004.
Okay.
To what degree they've actually done that, I don't know, but since 2004, and that's acknowledged in the FCC order of January, they've already had that permission. And for longer than that, they've had the license to be in the Iridium-like business. But the Iridium-like business, frankly, despite Motorola's fondest dreams in the early 90s, is not a commercially viable business because big, heavy satellite phones are basically only cost-effective in disaster areas and really rural areas. So Motorola thought, when they proposed that there'd be general demand for Iridium-like phones, but it's clear that, after 15 years, I was involved in the original policy of that, and it's clear that Motorola's expectation, not to mention the fact they went bankrupt on the original proposal, was unrealistic. And so basically this band and other bands made for similar use are lying fallow. So one of the public interest questions is, if we're desperately looking for spectrum to get more mobile connectivity, there is a public interest cost, maybe not an absolute, of letting this band lie fallow because it was set aside for one use that seemed reasonable in the 90s, but realistically that use doesn't exist because of cell phones that, you can buy cell phones with 4 different modes in it, and nobody uses it, nobody buys Iridium phones, and they never really did. And you see them on the evening news transmitting from Libya, but that's about the only time you ever see an Iridium phone.
So, hearing you, it sounds like the opportunity cost of not leveraging the opportunity to go terrestrial and satellite makes sense for Light Squared. However, there is the fact that it's so closely aligned to what you earlier spoke to about the GPS allocated spectrum. How closely are those two aligned in a technical sense? I mean, numerically, I see how they line up, but being so close together in terms of a spectrum address, can you explain to me what the real concern is? It seems like if you're in your lane, everything's okay, or your spectrum.
Okay. In the real world, real receivers, as opposed to theoretical receivers, have trouble receiving weak signals with a strong signal next door. Especially receivers that cost consumer grades amounts of money have a problem. You may recall when we had UHF analog TV, that only 1 out of every 6 channel was used. So here in Washington, we had 14, 20, 26, 32, six increment. That was to protect receivers from the real limitations of receivers when there are multiple signals present. Theoretically, when I studied electrical engineering, you could have receivers receive independent signals right next to each other. But real receivers, particularly ones of finite cost, do not have arbitrary resistance to strong signals in the adjacent channel. And this channel goes up right adjacent to the GPS band, and up till some number of years ago, everybody thought the only thing that would be in it was Iridium signals from the satellites of the Earth, which would be roughly comparable in strength to GPS signal, not significantly stronger than GPS. However, since 2004, Light Squared's predecessors have had permission to do things in this band, and an amusing question for the GPS community is, what have you been doing since 2004 when Light Squared had some permission to use this band? Because this resistance, although it's inevitable, the exact amount of it is not a fact of nature. It's a function of how much money you spend on technology, or conversely, do you use the latest technology? So the filters that are used in GPS receivers to get rid of the adjacent band signal are adequate for what happens today on a day-to-day basis. Apparently, from my sources industry, they are not comparable to the best filters that are used in cell phones, for example. Because in cell phones have a more stressful environment, So the cell phone manufacturers ought to put better filters in. This is not unreasonable engineering. Engineers not only design things that work, they design things that work subject to realistic constraints, size, weight, cost, and whatever. And when a certain level of component is adequate, why spend money redesigning it just because better filters are available? However, since 2004, LightSquared has had an authorization here, and I would be curious to ask the GPS people, you know, what have you done since 2004? Are you even using the state of the art, which if you took the best cell phone technology and moved it down to 1575, how well would it perform? But there are no filters in production today that are significantly better than what they use, but that's because what they've used has been adequate. Just like for UHF TV receivers, as long as we had the old analog system, nobody put really good filters in UHF TV receivers because the FCC guaranteed there wouldn't be a strong signal within the next 5 channels going up or going down. So there was no incentive for engineers to spend effort to designing that. Now, the other interesting that most people don't mention, if you read the January order carefully, in the spectrum that LightSquared has, which is 1525, 1559, with 1 megahertz missing in the middle, the FCC order in January has a clear provision in it that they can't use all of it. They have to reserve 6 of it only for Iridium-like systems, the weak signals. And now I'm not sure if they can put all 6 at the 1559 end because they have other signals they have to protect. For example, Inmarsat, a system that was meant to transmit to ships, which is not, ships aren't in major cities, but as it turns out, Inmarsat does things other than ships. And if you read the FCC filing, it turns out wheat farmers use Inmarsat signals in connection with GPS signals for measuring the position of a plow or fertilizer spreader better than your car GPS can, because in certain types of farming, it's important to distribute different amounts of fertilizer in each section of your field. So there are real economic benefits to that. But the wheat farmers use the Inmarsat signal legally, but to fine-tune the GPS signal. So there are several things they have to protect, but they have 6 megahertz they basically can't use for the strong signals. And you know, if they put some